Okay, here we go. So we have these topics, consecutive numbers, area and shapes, similar triangles, mixture of money, distance, rate, and time. We have work problems, and we just have tougher problems. Problems that, it's like, how do you start? Where do you even begin? I don't know. We'll just work through it. So we're going to cover consecutive numbers first. And so consecutive numbers, if I have a number x, and it shouldn't say consecutive numbers, should really be integers. What would be the next integer after x? X plus 1, and the one after that, and x plus 3, so on and so forth. So we have expressions for consecutive integers, okay? Consecutive evens. Did I get you guys your stuff? Oh, I didn't. I'm sorry. Yell at me. Say against. What's going on here? I didn't forget about the middle group this time. Okay, here we go. Evens. Oh boy, I got an integer. How do I make it even? 3 plus 2 is 5. 1 plus 1 is 2. 2 plus 1 is 3. Okay, make an integer even. What do I do to it? Multiply by 2. Very good. So you take any integer multiplied by 2. I promise it'll be even, right? Give me an integer. 4x, 4. 4 times 2 is 8. Give me another one. 17. 17 times 2 is 34. Anything multiplied by 2 will be even, right? As long as it's an integer. So what would be half? It has to be an integer. Integer. So 2x. What would be the next even integer after 2x? So let's say x was 3, 2x is 6, 4x is 12. So we're missing a number in there, right? So I want to go from 2x. I want to go 2 forward, correct? 2x plus 2. And after 2x plus 2, 2x plus, and after 2x plus 4, 2x plus 6. Yeah, so those are my next ones. Ooh, want to make something odd. I want to make it odd. First, I'll make it even. Plus 1, yep. So the one after that, 2x plus 3, 2x plus, and 2x plus 7. Very good. Good, you got the idea. Let's apply it and do some word problems. Find 4 consecutive odd integers whose sum is 80. Now, some of you guys are thinking about this right now. You're like, well, divided by 4 right now, we're at 20. So like 19 and 21 and 17 and 23. Yep, those are the 4. But you're not going to be able to just do that on the test because I have to help you develop problem-solving skills to where you can actually write out a mathematical equation. Because otherwise, you have no chance of doing this problem. I mean, you would be stumped. Okay, this is not something you could just try a kind of a guess and check method and do some voodoo math with. Doesn't work like that. So we have to write expressions, and your test, part of your test will state that you have to write the mathematical expression that equates this. So 4 consecutive odd integers. So my first odd one will be 2x plus 1, then 2x plus 3, then 2x plus 5, and finally 2x plus 7. So it says find 4 consecutive whose sum is 80. So I want to take all these 4, add them up, and I get 80. 2x plus 1 plus 2x plus 3 plus 2x plus 5 plus 2x plus 7 equals 80. So that's the equation I'll be looking for to make sure you understand that you can write it in that way. Now I'm going to add them up. How many x's do I have? 8x. And then what do my constants add up to? 16 is equal to 80. Solve. 8x is equal to 64. Divide by 8. X is? Good. Is that my answer? Why? Yeah, I got to plug it back in. So 2 times 8 is 16 plus 1 is 17. 2 times 8 is 16 plus 3 is 19. so on and so forth, and you're going to get these four numbers. Does that make sense? Okay, let's try something a little bit more challenging. Two consecutive squares whose sum is 613. What? Give me an example of consecutive squares. 4 and 9. Okay, good, because 4 is 2 squared, and then, 2 squared, and then 9 is 3 squared, right? So you have x squared, and then you have x plus 1 squared. So those are consecutive squares. See how I did that? So whose sum, so we'll add them up, x squared plus x plus 1 squared is equal to 613. How do I square x plus 1? Boil it out. What do you get? 2x plus equals 613. Good. By the way, Tenley says hi to all you guys. Very good. So if you take x plus 1 times x plus 1, that's what it means to square it. I have to multiply each part, and I get the 2x. X times x is x squared. X times 1 is 1x. 1 times x. Right here. So if x was 2, then I plug it in here. 2 plus 1 is 3. You wanted x squared plus 1. Why it's not like that? Because, okay, good question. So if we plug in 2, we get 4, right? Now plug in 2 here, you get 4 plus 1 is 5. That's not a perfect square, is it? But if you plug in 2 here, 2 plus 1 is 3, and 3 squared is, and that is a perfect square. So this works. This does not. Yes, yes. Okay, so we get 2x squared plus 2x plus 1 is equal to 613. What should I do? What are your thoughts? CTS. Excellent idea. I don't really like using it, but if you want to use it, go ahead, free country. I'm going to factor. I like to factor better. So I'm going to factor out a 2. So I need two numbers to multiply negative 306 that add to positive 1. That must mean they're really close together, right? So let's see. 16 times 16 is 256. 17 times 17 is 289. 18 times 18 is 324. So I bet it's probably 17 and 18. If you take 17 times 18, you get, yep, 306. Okay, we got our two numbers. 2 times, we got x and x. Which one's positive? Okay, so algebra allowed us to do something powerful, which is solve a bigger type of problem. So what are my x values? And are those my answers? No, the question is the two consecutive squares. Plug in negative 18. What's negative 18 squared? 324. What's negative 18 plus 1? Negative 17. And negative 17 squared is 289. 324 and 289, they do make 613. So did the negative 18 work? Yes, and it produced two squares, 289 and 324. But try 17. 17 squared is 289. 17 plus 1 is 18 squared is 324. So you can see that either one you use for x will produce the same results, namely that 289 and 324 are your consecutive squares that do sum to 613. So you have to make sure you answer the question. That will be worth a point on the test. You can do all the work and come up with negative 18 and 17, but if you don't answer the question properly, you will not be given full points. Turn it over. We're done with consecutive numbers in practice. We'll give you some work to practice that. We're on to shapes and area and volume and things of that nature. So this problem, a rectangular garden has perimeter 288. If the length is 4 more than twice the width, what are their dimensions? Oh boy. What do you want to do? Draw a picture. Who said that? All right, very good idea. We draw a picture because we are visual learners, every single one of you. And we have width and we have length. Good, got a picture. Growing carrots in my garden. Oh, we'll play a game. I'm growing apples in my garden, but not oranges. I'm growing books in my garden, but not shoes. Yes. You're growing hammers in your garden, but not screws. Very good. Excellent. Anybody else? Yeah. You're growing kids in your garden, not cats. That's so good. Somebody else? Come on. Jack. Jake. Go. You're growing puppies in your dog or your garden, not dogs. Very nice. Anybody else? Come on, Jack. Step up, big man. I'm growing knees in my garden. And I'm growing feet, but I'm not growing hands. Okay, we're done with the fun. What do I do now? Formula. What's the formula? Yeah, you tell me. Good, excellent, way to go. So 2 times the length plus 2 times the width is equal to 288. So she's got the formula, but we got 2 variables, and therefore we need 2 equations. 2 unknowns needs 2 equations. 3 unknowns needs 3 equations. 4 unknowns needs 4 equations. We got 2, so we need another equation. So I got to use something else up here. What can I use? Yeah. Oh, what a smart guy. L equals 2W plus 4. It says length is 4 more than twice the width. Now I can do what with that? Substitute 2L plus 2 times, other way. 2 times 2W plus 4 plus 2W is equal to 288. 4W plus 8 is equal, plus 2W equal to 288. And 6W plus 8 is equal to 288. So 6W is equal to 280. So W is equal to, somebody got a calculator? 46 2/3. So am I done? What's the question ask? Dimensions. I have the width. The width is 46.6 repeating feet by, how do I figure out L? Plug it in. 2 times 46.6 repeating plus 4 gives me 90, what, 3.3? 7.3. There we got it. You've seen problems like this before, haven't you? But the difference was you spent a whole day solving them, okay? Now we're going to see 6 different types of problems in one day, okay? So you can learn to just see the difference between them. This type of problem right here, example 4, comes up in calculus. And so it's good that you see it for the first time here. Oh, I need a demonstration. I can't hear you when you're out there. You're going to have to come in. What up, dog? Are you done? Yeah, come on in. Learn. Free country. Do what you want. He's just chilling. All right, so Okay, box, square base. Square base, no top. To be made from a square piece of cardboard by cutting 4-inch squares from the corner, holding up the sides as shown in the figure. You can't see the figure, so I'm going to show you what we're going to do. I give myself a square base, approximately. There's all estimation. If you can me. So we got the square piece of cardboard. And I'm going to cut squares from the corner. We call it squares. There we go. So I've cut the squares, and now I'm going to fold over the edges. And as I fold over the edges, it will create a box with an open top, right? Wow, you like that? Okay, great. So, can you, if I no, still can't see that, can you? Okay, video can't see it. That's all right. Can't just throw that on a smart board. So that's what we're doing. Okay. So we're going to take this type of shape is what we did. We got square, x by x, and we cut these corners off. What do the corners measure? 4 by 4. Good. Now what? What do I need? Starts with an F. Formula. Give me a formula. Come on, you're my geniuses. What are we trying to find? We got volume, right? What's volume of this figure? Give me a formula. No, not 1/3. How many dimensions do we have? 3 dimensions. So we multiply base times width times height, or length times width times height. There we go. 1/3 is when we do like cones, we do spheres, or yeah, pyramids, stuff like that. This is just straight up volume of a box. Multiply 3 things together and you got your volume. Okay, that's all I got. So, which one of these do we know? The height, what is it? 4. Why? Yeah, you folded up the dealio, and that gave you the 4 on the side. That's what you cut off. Okay, so good. Height is 4. Got it? Would you agree that the length and the width are the same? They sure are. And I'm going to say that if I were to fold along this line, that I know what this is right here. X minus not 6, but x minus 8. Since I cut 4 off the top and 4 off the bottom and 4 off the sides, I'm going to have x minus 8. What is the volume? Not a trick question. What's the volume? 100. 100 is equal to 4 times x minus 8 quantity squared. That's a nice equation, right? So now what? Divide by 4, 25. Now what? Square root. Square root of 25, I have to list 2 choices. Plus or minus 5 is equal to x minus 8. Now what? What do I do both sides? Add 8. So if you add 8, you get 8 plus 5 and 8 minus 5. What's 8 plus 5? 13. And 8 minus 5? Which one's right? Or are they both right? Why? Yeah, 3 represents the original length and width. And if you took 4 off of each side from 3, that would leave you with a grand total of -5 left. Right? Okay. So how big of a piece of cardboard? 13 inches by 13 inches. Sure, there you go. Okay, great. Get it? See that? Yeah. Because if we cut off these, so I cut these squares right here, and you can see that, so this has a length of 4, and this has a length of 4, and when I fold it up, that gives me a height of 4. And you guys, all the questions you're asking are questions that people ask every year. The big question is, do you see why the picture works out the way it does? Like my little demonstration. Because in other years, I don't do the demonstration. You guys seem like you kind of understand it a little bit. You don't like it? You like it? All right, all right. So prize. All right. Yep. For just $2, I'll make you one after class if you want. Okay. I will even I will even autograph it. Oh, were you born mean, or did that happen over time? That okay? All right. Okay. All right. We got 2 more. What's your mom's name? Cheryl. Okay, we'll ask Cheryl. We'll ask her. I'll give her a call. Give her a call. I will. She does? All right. Right triangle. Hypotenuse, 12.5. The right triangle. So I'm going to put that little thing there. Cool. One leg is 8.5 inches longer than the other. What's the area of the triangle? What to do, what to do, what to do. Pythagorean theorem, yes. Give me my labels first. X and x plus 8.5, and Pythagorean theorem is a squared plus b squared equals c squared. One of the greatest formulas in the history of mathematics. So just all of trigonometry is based off of that. So all second semester is basically, we just call it Pythagoras on steroids, and that's what trig is. Okay, it's awesome. All right, so what's a squared? X squared plus x plus 8.5 quantity squared is equal to 12.5 squared. I'm going to 8.5x and 8.5x will make 17x. 8.5 times 8.5. 72.25. And 12.5 squared. All right. What to do, what to do, what to do. Zero it out. 2x squared plus 17x. Subtract that 156 over, and I get 84. Now what? 3 options. Put square, factor, quadratic formula. You have the quadratic formula on your calculator. All right, use it. Take it out. On. Program. Execute. Enter. And then it'll say program quad. Press enter again. And it'll ask you what A is. What is A? 2. Enter. 17. Enter. Negative 84. Enter. What do you get? Negative 12 and 3.5. So which one could be my answer? I will use 3.5. Not the negative 12, right? Well, I'm going to ask you a bigger question right now. Do you see why the mathematics comes up with a negative 12? Because a negative times a negative is a positive. The mathematics understands that you can still come up with that area that you want to. but it doesn't know I guess the limits of our world that we can't have negative length. It doesn't know that. We're the ones that put the limits on that. You know what I mean? The mathematics is why not have negative lengths? You know, you had negative times a negative still gives you the positive. It will give you the same answer as 3.5 would. So our dimensions are 3.5 by 12, right? So how do I figure out area? 1/2 times base times height. So 1/2 times 12 times 3.5 should give me 21. What's my label? Inches squared. Now, you guys, I would expect that you could do the quadratic formula by hand. I would expect you could factor that AC method, whatever you want to do. But I also know that on the ACT, you get to use your graphing calculator. So quick, press quadratic formula if you get that kind of a problem. Go with it, right? Okay. And flip it over. Last problem, 21. 21 inches squared. No. Really? Okay, so we'll pick up this tomorrow. We finished this in the other class, just barely. Look at the very last part of your notes. See this? 1.6 word problems. You are currently able to do problems 1 through 8. That's your homework.